Hi, good day, everyone. I hope you're having a great first day here at TestMu. I am Navya, and I'll be your host for this session. So, it's a great pleasure for me to introduce you to our speaker, who's going to be talking about testing strategies for micro-frontends. So, this talk is going to take us through the basic setup of each frameworks, which will include Cypress, RTL, While, and React. We will also learn how to configure Cypress and RTL and why White might be better than Webpack. So this talk will show you smart ways to test that both new and useful in real situations. Our speaker for the day, Ioannis Papadakis, specializes in QA engineering with over 13 years of experience in tech. He is a valuable asset due to his commitment to learning agile methodologies. In his current role as a director of quality assurance at GWI, Ioannis shapes testing strategies. I've also had the pleasure of collaborating with him on a few of our projects as well. And it's great to be hosting him today on TestMu. So please join me in welcoming Ioannis Papadakis. Ioannis, over to you.
Thank you very much, Navia. Really great introduction. I'm going to share my screen a little bit, starting now. So give me a few moments so my presentation is ready. Um, so I'm going to summarize. I think Navia told all the nice introduction about the talk. It's going to be about micro-frontends. We're going to discuss why we chose to develop our front-end application based on micro-frontend architecture, and how we're going to do testing, how we can apply a more modern testing pyramid in our micro-frontends. So you know me, just a familiar face as well. I'm working as director again, as Navia said, on GWI. I recently joined the Lambda Test Spartan program. It's really nice. I always say, everybody, if you want to exchange knowledge, join these community-based programs. It's really great. So maybe at another time we can speak about it. So the agenda for today is a brief introduction about the micro-frontends, the micro-frontend architecture. We're going to discuss about testing strategies in React, micro-frontend specifically, architecture. And after that, non-functional testing, what type of non-functional testing we can apply as well in our micro-frontend architecture. And in the end, we will wrap it up everything and see how we can actually run everything in a continuous integration environment, how we can achieve continuous deployments, how we can optimize and scale our tests through GitHub Actions or Lambda Test Cloud environment. So to start with, I will start with the UI monolith. This is the first part. So to describe where we are before choosing the micro-frontend architecture. You can see here all the different services in the backend formulates the whole backend structure that we have in our application. All of them are different microservices, but in the front-end side of things, we have only one part. So we have a monolith in terms of the UI, of the user interface. So what about micro-frontends? What is the difference here? Is we chose this to mimic the behavior of the backend in the frontend. So we wanted like different microservice to be called from different, let's say, part of our frontend application. So in micro-frontend, it's actually an architectural design approach to break down the monolith that we have in the user interface to smaller parts that can be managed very fast, and we can deploy each of them separately for our application. So if I go a little bit and think why we should choose this architecture, micro-frontend actually can be isolated, so you can actually test it isolated. That's one of the benefits as well. So the micro-frontend allows also the development teams to be more proactive. They can actually make changes without affecting from other parts of our application. So we don't want, for example, if I have a micro-frontend for my user authentication part of the user interface. Let's say I don't want to be affected from other parts like shopping carts of the application. So the teams can be isolated, they can make changes proactively, they can actually also innovate, if you get my feeling. They can do a lot of stuff, they have a lot of independence. So although the micro-frontends are not only to the web limited, they are very effective on that part. So let's see some of the benefits one by one. We have flexibility on the design and the development. As we said, you can pick any development stack. You can have different micro-frontends, and each one, based on your team, based on your engineering team, you can actually choose if you want a different technology stack, but the best is to have a common technology stack across your teams. You have separate code bases, meaning that you can isolate your code base. Your tests actually follow the same structure. You have your tests in a separate code base. You have native browser over custom APIs. So this is really important to remember that the user's browser will impact how the app overall is experienced. So since the micro-frontend architecture relies very, very nice to the browser events for communicating different micro-frontends instead of the APIs, it's really much simpler to maintain. You don't have to maintain APIs anymore. You have freedom to innovate. As I told you before, you can do a lot of stuff around it. You have a fault exclusion. You can create robust apps, which is crucial benefit here in the design. So you don't have a risk for the whole system to be falling apart if a micro-frontend application, it's not operating appropriately. But if you have a monolith, you find out that you have a more coupled way on the errors and the faults of your system. You have faster build time. You can actually deploy much faster your application. Technology agnostic is that you can pick any technology if you want. You have autonomous teams. They can work isolated. They can deploy their micro-frontend isolated. And you can understand we have maintainability also benefits. We can maintain more faster, smaller parts of our system. And you have the reusability. You can reuse stuff for your system very, very quickly. So see, these are some of the benefits why we chose, let's say, the micro-frontends. Let's say the questions are raised when in GWI we started facing this problem, how we're going to develop the UI or split down the UI to different micro-frontends. So one of the basic questions is which parts of our system we're going to slice it. So which parts, how many micro-frontends should we have in our user interface? In the same way that happens from the backend, saying how many microservices we can develop in the backend. So there is a crucial point there. Don't overexceed the things. You don't split a lot of things together to separate micro-frontends. You will find out the next part is how we communicate between different micro-frontends. So there are a lot of solutions over here. When we're dealing with React, especially with React, you can lift the state using props and callbacks. This is one of the approaches that we followed. So you can share, let's say, small interactions between your micro-frontend. And the last part is, okay, we are done developing our React micro-frontend. What about testing it? How should we approach the testing phase on the micro-frontends? And in this slide, you will see like a fully functional example of the testing strategy we followed. We have the React unit tests, which is the fundamental part. We want to invest more on the unit testing layer. We have the integration tests that can run in the isolated micro-frontend environment. We have the end-to-end tests that can run on a real environment like staging or production. We have actually to deploy, if you want to have a continuous delivery approach, your pipeline should deploy on staging and production. And everything is wrapping up around CI/CD. And here in this stage on the CI/CD, we can speak a little bit later about SLOs, but it's not part of this presentation, meaning that, we made some agreements within our engineering teams regarding how fast we deploy a micro-frontend and how fast the testing phase can take in order for the engineering teams to be more productive. And in the end, we have the non-functional testing that we're trying to shift left this part of testing as well within the development of our micro-frontends, like performance testing or accessibility testing or even visual testing, if that matters. So and then in this one, I'm saying the traditional testing pyramid. I think everybody knows that, right? Everybody in the QA community understands that there are different layers. So the pyramid is a different framework saying, oh, we need to invest more on unit, less on integration, and more or less on acceptance because you have, the maintenance and the cost is actually rising as you are going higher in the pyramid. So here, the shift-left testing approach. We knew that when we started, and especially we chose micro-frontends because we knew that we're going to split the tests in segments. Like we have different code bases for its micro-frontend. We need to do shift-left testing. We need to be proactive. We don't want to test when we are deploying in a real environment rather than we want to test earlier, right? So earlier means we fix issues with the engineering teams earlier in the phase in all of the types of tests we're going to see later on. So why do we do shift-left testing? Which is we need higher quality code base, especially in the micro-frontends. We have multiple code bases. We have better maintenance over the quality within the micro-frontends. The product overshoots estimated timeline. Of course, we have higher quality product. We know that the value is out of it. High customer satisfaction. They are very satisfied because we get releases that are as much as possible with no defects, right? We reduce cost of solving a bug. Like if we find a bug in early stage, we can solve it much faster than finding it like in later stage. What's the development workflow for each micro-frontend? You see here, we have each micro-frontend we can deploy separately in a development environment. We're going to see later on, we don't want to have like real requests that going to the backend, to our backend microservices. Really, we need an isolation also from the backend. We perform the test-driven development approach, meaning that we write the tests, we make the test failing, everything is running as part of the CI pipeline before deploying or releasing our micro-frontend. Then we have a testing environment that we can actually deploy isolated each micro-frontend. And the same way goes after that to another environment, can be staging or production. You can have UAT. This depends on how your teams are actually handling the environment within your organization. A few words for unit testing. So here, the stack that we use, we're talking today about React. So we use React testing library to test isolated components, React components of our micro-frontend. We use the mock service worker, which is a library that is mocking all the backend requests. This is really important when you are doing even the integration test we're going to talk about later. We want to test the functionality of our micro-frontend rendered in a browser, in any browser, but without affecting from, for example, the backend, how the backend responds back to the frontend. We don't care about it right now. And the Jest code coverage, which is the Jest library integrated, it can give us some high overview of how much coverage we have in our tests. So the problem, why do we use unit tests, which for a lot of people it's really understandable. We want to write more maintainable tests. When it comes to maintenance, the unit testing layer is the one that is actually giving us a lot of support in the maintenance. We want to have maintainable tests for the React components. We want to avoid including any implementation details about the components. So we want to focus on making the tests more robust, more reliable for us. And that is the problem, and that's why we had the solution of the React testing library. A lot of other actually testing frameworks like Cypress or Playwright provides a way to do component testing in React nowadays. We chose React testing library. It was close to the engineering team, but you can experiment with other frameworks as well. It's just one side of, one framework that we experimented in GWI, and, the teams of the front-end engineers are really very, very close to that. So the MSW, how it works, we have the test suites. We use Jest to run the suites, to collect the coverage as well. And we make requests, and MSW works as a proxy, doesn't leave the request going to the backend, so it serves back a mocked response to our test. A typical example you will see here in the presentation of a RTL unit test with also using the mocks. You need to start the server, the mock server, and then serve all your static fixtures into the tests. So why we use the MSW? It's deviation free, it's familiar and very powerful, it's seamless. So this is the three pillars of why we eventually picked up MSW for that. And later on, we're going to see MSW operates very well with Cypress as well, or Playwright, if that matters. And if you want to do like a unit and component and integration test for your micro-frontend, at the same time, you can use the same mocks for all the level of testing you have on your micro-frontend. So some of the advantages, we have composable functional syntax. It supports REST APIs and GraphQL. It has native TypeScript support. We developed our micro-frontends in React on top of TypeScript. So it has a very nice support as well there. We have a client-side execution, and we have interception on the network level. So this is about mocking for our unit tests. Let's go a little bit, later on to see, as we talked about in the beginning, we have Webpack versus Vite. Why use Vite to migrate to Vite for our React micro-frontends? So a few words is that, most profound here is some of the saving in terms of the time or on the building time of our application. You see, like moving to Vite, a view app, for example, you can see 60 seconds with Webpack, and how we reduce like 3 times the time using Vite. So most profound reason to go to Vite is the build time. I will explain a little bit that, before having ES modules, before ES modules were available in the browsers, so the engineers didn't have a native way, let's say, for authoring the JavaScript in a fashion that can be modularized. So many of the front-end engineers are very familiar with the concept of bundling. So there are tools that can crawl, concatenate the source like JavaScript or static CSS files, everything that can run inside the browser. After that, over time, we had Webpack, we had Parcel, now it's Vite. There are new tools coming up. They really want to improve the development experience. So we see here the example of the Webpack. So the Webpack tries to take all the assets of the web project and bundle them in a smaller number, let's say, of files, so it can be downloaded by the browser one by one. So in order to perform the bundling, Webpack follows also a way of importing required statements inside the code, in order only to include the files that we are actually need to include. So this is the way the bundle-based dev server that the Webpack is taking into account. And this is a way that the Vite has. So with this setup, with the native ESM-based dev server, unnecessary bundling during development is avoided. So the build time, you get an understanding, it's fairly greatly reduced. And deploying and building our micro-frontend application is much faster. So Vite.js, that's actually doing 2 main things. It's serving code locally during the development, and it's bundling all the front-end assets for production. Let's see, let's go a little bit one step further here and see about the dependencies that we need for coverage. Here I'm saying that we use the instable libraries for setting up the code coverage dependencies in our React micro-frontends. One of them is the instable NYC config TypeScript, and the instable badges README and lib coverage. The first one is actually a way to update our code coverage within our README files in the GitHub repo, as I state here. And the first one is instrumenting. We need to instrument our TypeScript project in a way that can be actually uncover the code coverage results after the test being run, both unit and integration tests. And what about testing? So with Vite, it's pretty simple. One of the scripts that we use, which is pretty fast, you can run your test with the Vite test command. And if you use the minus coverage, you pass this argument, you can actually run your unit RTL tests with coverage mode enabled. So this is all about unit tests. Let's talk about a little bit about integration testing. So integration testing, it's one it's one type of testing we wanted to have in the micro-frontends before going to a fully deployed environment. We want to start a browser, any browser. We can do cross-browser testing as well on this level. And actually, we wanted to test the functionality in terms of the end-to-end flow of a user. So we want to uncover any problems rendering our micro-frontend application in any browser engine, which is pretty different in terms of the RTL and the unit level or the component level, because at that level, you just like load the DOM in a headless mode. You are not testing in a real browser or anything. So it's a different type of testing, meaning different type of defects that we may find for our micro-frontend. So the solution here, we experimented with Cypress. The presentation is about Cypress, but don't limit yourself in any testing framework. You can pick up Playwright or any other framework if that matters. And it's actually pretty easy to integrate within your development flow. So with Cypress, it was easy for us because the engineering team already used Cypress in the past to do the end-to-end flows of staging on a real deployed environment. So we took the same technology stack, embedding this technology stack within the engineering teams. You see the flow, the design that we chose. We wanted to have a maintainable design. We needed to have some abstraction levels. A good design means you have more maintainable tests. Your engineers are more comfortable. You can control the flakiness at some sorts, in terms of your code. So what we did is we defined page objects. A way to define actually the DOM itself for its micro-frontend. Though the micro-frontend it's a small piece of your whole application, you can actually have multiple page objects even for one single micro-frontend. And we separated in different commands API for Cypress, for UI and API. For example, you can do UI actually calls within your micro-frontend, but you can also, if you want to do some more contract-based testing with your backend microservices, we separated that and we used Cypress defining a layer on the commands API. So one example of the page object model is here. We're just defining the page object. Here you will see the DOM mapping. So actually we're defining the DOM selectors within these pages. We don't define actions, rather than the actions are part of the Cypress commands API. So we changed a little bit the logic, because in some terms in the QA community, page objects can also have functions that actually do a user interaction, but we didn't want to do that. We wanted only to simulate the DOM mapping within our page objects. So in the end, you will see a commands API for Cypress. You will see the chainable interface that we declare the functions that we want to implement. The actual functions are displaying a specific business operation from the user interface for this specific micro-frontend. And internally, you will see that we're calling the Cypress API. Eventually, the test is not actually calling any Cypress commands. We import our commands API, the custom commands APIs, and we interact with them. So we needed an abstraction level. We needed to make sure we maintain a good level of clean code principles, let's say. Another example, this is a commands API. We use the request API from Cypress to do API calls and make sure we have some type of API testing with a backend for its micro-frontend. And I will go a little bit, then you will see the test. This is the final test. You see we call even the custom Cypress API within our test, or we call the page object, we call the selectors within the page object or the elements of the DOM, and we operate with these elements within our test. So we, let's say, cover all the Cypress API within our tests to make the test more maintainable. And let's talk about mocks. We talked about Cypress. They are going to be used for integration testing, but we want to use mocks as well. We want to reuse even the mocks that we had in the previous step on the unit testing layer. So when using Cypress, a lot of people are very familiar. We need usually to mock the API responses in different phases. It's more controllable for us. We want to make our tests more fast for the engineers, one of the things, the benefits. You don't have a really an integrated environment around this. So Cypress has the intercept commands that you can use, and you can intercept your APIs and provide your own fixtures, your own mock data into your tests. Because as I said, this type of tests in the micro-frontend, it's not about testing the whole communication between your microservice and your micro-frontend, rather than only focus on one thing, testing the functionality of the micro-frontend. Another example of the MSW, but now with the browser, we load the tests, the Cypress tests in the browser. We use a server worker that actually do clone the request for the MSW, and the MSW is returning the mock response back. So we cut off the communication 100%. Record mocks. One of the challenges we found in TWI, we had a very big pool of tests, right? And in the beginning, we had the different micro-frontends. The challenge we found out is that, why not, capture the network traffic somehow from our tests, and give us a way to actually produce the static fixtures, actually the mock data, without creating our own mock data. So we said there is one coin which in one side we have MSW, which needs from your engineering teams to provide and maintain the mocks. And the other side of the coin is we have a big pool of tests. How we're going not provide our own mocks, rather than find a way to capture the traffic, actually the HTTP requests that are actually performed from the micro-frontend, and produce this in an automatic way. So Cypress replaced a library. It's an npm package. The community already developed that. We found that it's a way that we can have an intercept pattern. And if you enable the Cypress replay into your Cypress scripts, you will capture the traffic, and this traffic will be re-forwarded to a JSON file, which is a static fixture. So if you have a team that they already have a big pool of tests in your project, you can start. The optimal thing is to have MSW with mocks. But you can start using this in order to avoid some time, in terms of execution time. It's really speeding up the development. And what about Zod here? Zod, it's a TypeScript first schema declaration validation library. We use Zod in order to validate the mocks. It's very, very powerful because at some point, these mocks are actually contracts between your microfront and the microservices you have. So you need something to validate if the contracts, if the mocks are actually correct based on the backend. So Zod is actually doing that. It's validating the schema of the mocks based on the backend requests. So Zod and TypeScript, we have mock data into fixtures, and in the end we use hyperfail on console error library. It's a package that we want to actually fail the test if we have console error, because the Zod is actually producing a console error if it's validating the mock data, and if they are failing, it's producing a relevant issue on your console error. So what about code coverage? So not to stay behind, we have React app instrumentation here. The difference is you need to find a way to do instrumentation on your React application. And you have the Cypress code coverage, support, which is already provided from Cypress team. Invite, it's really interesting. I see here, I show you both cases, both Webpack and Invite, how you can do instrumentation in your code in order for your Cypress test to be able to perform code coverage. Invite, this is the section with Instable that says we use Cypress, for example. You need to have force build instrument true if you want to instrument your application. Otherwise, if it's false, it's going not to be measuring your coverage as well. We use also two ways the NYC module, which is a command line interface for the Instable library. We're going to see, because we use this module in order to have a combined code coverage between unit tests and integration tests. And the other way that some people are using is having the code coverage as part of the code transpilation pipeline. So there are tools that can do actually instrumentation as part of the code transpilation. And this is the Cypress configuration. You see the end-to-end TypeScript file. You import the dependency, which is the dependency for Cypress code coverage. In the end-to-end section, you need to register the task for the code coverage. So in order for the test to start measuring anything in the background. So you see here an example. In the left, you see the tasks that are registered when we are starting our application and we are finishing our application. Some of the tasks are registered. In the end, we produce an HTML report, which is nice. Everything is really plain, very, very simple to integrate Cypress code coverage on your React micro-frontends. In the end, the combined coverage, we want in our CI pipeline, we run all type of tests when we run the React micro-frontend deployment. We have unit tests, we have end-to-end integration tests, so we use the NYC to actually merge everything. And this is part of the script we created. So we use the command line interface of this library to actually merge different type of coverage results all together to have a combined report in the end. I'm going a little bit faster here so we can cover other areas. Non-functional testing. So we covered functional in terms of unit and integration with Cypress. What about non-functional testing? We want to have K6, for example, covering some of the performance tests for our micro-frontend. Or we can have Axel library for the accessibility tests or even visual tests. I will talk about a little bit first about mutation testing. We haven't fully migrated in all the micro-frontends. We're still experimenting with mutation, but it's one of the parts that we want to invest moving forward, because one part is the code coverage, the other part is how reliable the tests are to detect, let's say, defects in your code. So the mutation testing, what it's doing, it's actually it's producing bugs programmatically in the code base, and it runs the test, and then it sees if the tests are actually capturing the bugs. So you have, in the end, the coverage metric, like the percentage of the coverage from your test, but also you have a mutation coverage, how many actually, how many bugs are actually uncovered from your unit tests, or even your integration tests. You can run both level of tests for mutation. Another type of non-functional testing that can run on micro-frontends, the accessibility. It's very, very nice, very easy to integrate within your existing Cypress tests. It's just a library, you integrate it, you have the existing functional tests, your existing integration tests. It's really nice to train your teams in non-functional testing areas as well. Accessibility nowadays is really important. You know that in the QA community already. This is one of the parts that we really want to invest as well internally. I'm also seeing InfluxDB and Grafana here because the monitoring part is really interesting here in terms of accessibility, because you need to monitor how well the accessibility violations are actually introduced within the development cycle. So we wanted a way of keeping historical data for this type of tests. So this is the accessibility, very easy, one API. You just inject your X library that do all the magic with the accessibility. You can have one custom command to actually scan the whole page or a single page or some sections. You can even have a different accessibility layer integrated within your tests. Make sure even that to be part of your abstraction levels, don't run accessibility checks within your tests if you have hundreds of tests. So you need to be proactive in terms of maintainability. And goes to performance testing, you see the K6, which also it's nice because K6 is on top of JavaScript. We run micro-frontends on TypeScript. It has also types for TypeScript support from the K6 team, which is really nice. I would definitely say if you have a React micro-frontend, include also performance tests. In terms of how fast the micro-frontend is rendering in any browser. K6 is doing that magic for you. It's really nice. It has the same technology stack in TypeScript that your front-end engineering team should use. It will be very well nice fitted in an early stage of your development. So this is part of each micro-frontend. We can have a K6 script or multiple K6 scripts, and we can actually capture the Google Web Vitals for an isolated micro-frontend. So you get an understanding, even the performance metrics are actually part of the whole development lifecycle in an early stage. You don't need to wait for a fully deployed environment to do even performance testing. So what's the ideal micro-frontend testing pyramid? For us, we have unit tests. We need to have mutation to make sure the mutation tests are complementary to the code coverage we are doing for both unit and integration tests. We have the end-to-end tests. We have accessibility. We have visual tests. We have performances that are the 4 top layers of our pyramid. It's different. It's it's our non-functional testing layers. You see that the cost is actually higher to maintain this type of tests, so your teams needs to be investing in each layer when you start developing your features, starting from the bottom. And the maintenance is really fast when, as you see in the pyramid. The final part of the presentation, we have around 5 minutes, hopefully, before any questions rise. I'm going to talk about CI/CD. We run our tests on GitHub. We want to have efficient SLOs, service level objectives. Of course, this service level objectives, it's not like between us and the customers. It's more of agreement between the QA team and the engineering team, how fast your pipelines are actually running and how fast you can deploy something like a new release on your production environment. So this is a nice example of the workflow. We have the pull request coming from the developer. We deploy the local app in a Kubernetes cluster. We run our RTL and Cypress tests. So the testing phase is working here. You can do like parallelization of your tests when it comes to Cypress and integration level. You want to optimize the tests. So what we did is, if you don't use a cloud vendor, and you use your own infrastructure, you need to have multiple workers running in parallel. Each worker is actually get different set of tests, and it's running. And then you upload reports on maybe on a Google Cloud bucket to be accessible from your engineering teams. And then you measure the coverage or either the mutation coverage here. And if you have a delta, you rerun the whole process again and again. So this is a part of a continuous integration pipeline. What's a part of a continuous deployment pipeline, which we are not there yet? There are a lot of challenges. When you say I release my micro frontend to production automatically, there are a lot of steps needs to be automated over here. So you have the development environment, you trigger your tests, you release your micro frontend, and you need to do a deployment to a real environment, which is staging. Now here, what our QA and engineering teams have done, which is really interesting, we took the Cypress tests that are running with the mock data within the micro frontend and actually running them in a real environment that actually deployed, like staging. So staging it's a state of different micro frontends deployed all together with a let's say a specific state of your backend. And we're running these tests. We know that there are changes that can be affected. So tests may be affected from other micro frontends because you have a micro frontend communication over there. So this part is when you need to have like a manual intervention, meaning that if it's failing, you need to roll back the deployment of the staging, inform the engineering teams, work all together with a fix, and rerun the same flow again. So this is the official image from Cypress, just an example. We created a script when you do internal, when you have your internal infrastructure, let's say, you need to create a script to split your tests in different workers on your Kubernetes cluster. And here the last part, which is uploading all the data like HTML reports, we upload them to buckets on Google Cloud, and then we can actually access them like code coverage results or even Cypress, mock awesome reports or whatever. They can easily be accessed through the buckets. What about scaling this? So as I said, one part is maintain your own infrastructure. You have your DevOps teams, they can support you. You can have your own Kubernetes cluster. You need to make sure you are maintaining your own Cypress image each time on your cluster that has different versions of browsers. And when it comes to the picture now, we have Lambda test, which is all about, you don't want to maintain all this infrastructure rather than have Lambda test doing that for you. So you can have cross-browser testing, you can have debugging. It has a lot of features. I mean, if I'm going to talk about Lambda test in the Lambda test conference, it's super nice. Maybe we can do a demo at any other stage or anything or another presentation. But I want to show you like scaling your tests. You can always have your own infrastructure or use a vendor. But the vendor has much more other features to cover for your engineering teams. So scaling your tests on cluster, I told you about. Here it's one example of the YAML file. You need to pick your container. You have a matrix-based with containers. Each container is actually a different worker on your cluster. And you need to pick a way to split your Cypress tests to different containers. So in order to do that, we created a script. This script is actually finding all your Cypress tests in your local micro frontend repo. It's splitting the tests. The example with the Lambda test cloud, super easy. It has a CLI, a command line tool. You can actually create your configuration file that describes which browser do you want, what are the credentials for your Lambda test cloud, and then you provide this into your CLI argument. You can actually even define how many browsers or how many virtual machines you want. So it's one example of this. As I said, Lambda Test Cloud, it's not only about the infrastructure in the browser. It has integration with test management tools, pretty much everything. It supports all the frameworks, all the test reporting tools. It has nice native support in all the continuous continuous testing environments like GitHub, GitLab CI, etc., Jenkins, whatever. So it's really like a platform not only for scaling your tests, but actually debugging your tests. It's a fully end-to-end flow for your test management. And this is an example of the Lambda Test Cloud. Each machine on the cloud, it can actually run each spec file of your Cypress test suite and run isolated. If I used Lambda Test before, I'm pretty sure if you want to have a DevOps team supporting your infrastructure and having a vendor that can support with so many other things, I would go with the second part. From my point of view, from my experience. So this is a kind of dashboard in the end that you see from Lambda Test Cloud, that you can see your Cypress suite running. It can have historical data for your micro-frontend as well. So conclusion, micro-frontend architecture in testing. It simplifies testing. You can isolate your testing in different parts of your system without being impacted from other micro-frontends. Testing framework, Cypress, Playwright, it doesn't matter. Just pick up the technology stack that it's really very common to your engineering teams, the QA teams. Even have your teams playing around a little bit with the frameworks. Don't hesitate on that. Incorporate non-functional testing like performance testing, or accessibility or visual testing. This part of tests should not be running on a fully deployed environment. The sooner, the better for all type of tests in your micro-frontend. SLOs and metrics, really important. Agreements to make sure the team is aware. They need to make sure how fast the deployments are being done for both your product teams, the engineering teams, and metrics. It's all about metrics. Find out how frequently you have flackiness within your micro-frontends, deal with the flackiness once and for all, measure it from my point of view. All this kind of stuff, doing that iteratively within your teams, your front-end teams, it's really a huge win-win situation between your QA and your engineering teams. Thank you. Sorry, I had 2 minutes over. I see my time. So we have a Q&A. I don't know if we have much time for any questions.
Yes, I think there are a lot of questions, but I think we can take one or two questions, and the other attendees, don't worry. We also have a thread running on the stock in Lambda Test community. So if your questions are not answered right now, you can definitely go and check your answers there later. But yeah, we will take a couple of questions and then we can wrap it up. So the first one. So, could you share insights on how testing strategies need to adapt to handle challenges of cross component interactions, ensuring compatibility and maintaining a consistent user experience across different micro frontends?
Yeah, this one it's a nice. I was expecting that question. So the thing is, when you are testing the micro-frontend communication, it's really difficult to do that in an isolated environment because the tests are part of the code base of each micro-frontend. When it comes to communication between different micro-frontends, you can either do that in a deployed environment, or have your teams working together, deploying, a semi-integration environment, let's say, which we haven't done that, to be fair, in GWI. So it's one of the challenges we faced. So keeping state between your micro-frontends is really important, and it's the difficult part of, this is how you are going to do integration tests, right? So you need to pick your battle here. I wouldn't go with a fully integrated environment, meaning that I don't want to be in, if I want to do a cross communication between two micro-frontends to fully deploy one environment with everything, rather than find a way with the engineering teams to test it, isolate it. So that I would go for. But to be honest, it's still a challenge for us, right?
Right. We'll take one more question and then we'll wrap it up.
Yeah, cool,
So,
cool.
this question says, could you elaborate on effective approaches for end-to-end testing? Specifically, how do you address challenges like data sharing, UI integration, and synchronization between micro frontends to provide a comprehensive testing framework?
Right. Um, okay, as I understand, data validation is not something that we are doing in the testing strategy, at least in the beginning. The integration test, as I told you about, we don't care about the data that are coming from the backend, so we're mocking this. So this part of testing is being done as part of a full integration environment that you can actually deploy together with your micro frontends. And even for that, you need to maintain your own data sets, right? You need to have test data provided from your teams rather than having like random test data that you need to test. So in terms of that, always, even for data validation, the teams should be involved. Now, again, I think the second part of the question is about the communication of the microfrontends. For that, you can apply a part of testing in an isolated environment, as I told you before, which is really interesting. I think it's something that it's challenging because you need to involve also the engineering teams, in terms of how you're going to deploy two separate micro frontends and test the integration between each other. So this is the challenging part of the strategy.
Great. Thanks, Giannis. I think that's it for today, guys. Other questions, please make sure you check out our Lambda Test community thread for all your answers. But it was a great session, Giannis, and it's always a pleasure to interact
Thank
with you.
you.
Thank you, guys.
Thank you.
Hope you have a very good rest of the day.
Bye bye.